Hi and welcome back. In this video we're going to look at adding new nodes to a binary tree. So this is the first step in constructing binary trees. Adding to a binary tree is actually surprisingly simple in its sort of basic way. We just have to make sure we add things to the correct side of the tree. For example, let's add the number 5 to this tree. Notice that the tree here has a starting point, what we call a head or a root of 14. Then to the left it's got 9, 9 has 13 to the right, 14 to the right has 22, and then 34. We know where 5 should go, right? Which is to the left of 9. But how do we tell Python to put it there? We're going to start with our new node. That is going to be this node object. A node object has 3 values, 3 properties. One, which is value. That's essentially the value we're trying to add. And then it's got 2 other properties, left and right. Those are the nodes that it has to the left and to the right. So we're starting with our new node that has nothing to the left, nothing to the right. It's not even added yet, and a value of 5. And we're also going to start with our current node, which is going to be the head of our tree. Let's say the tree is self, and the head is going to be the node 14. The first thing we must do is start a while loop. We're going to start a while loop because we're going to navigate through potentially many nodes until we find the one that we want to add to. So we're going to start a while loop, and inside the while loop we're going to say, do we want to go left or right? So if the new node's value, which is 5, is less than the current node's value, which is 14, then we will want to move left. So the first thing we do is we add this if statement. Is the new node smaller than the current node we're at? And the answer is yes. So, yes. What do? We're going to say, if the current node, which is 14, has a left node, then we're going to move to that node. Okay? So if current node.left is asking Python, is the node 14 left node something other than none? And at this point in time, it's yes, because 14 has a left node, which is 9. So what do? We say current node, which currently is 14, is now going to be equal to the current node's left. So we're essentially saying, move me to 9. And that's what we do here. Then we go back to the top of the while loop. So current node is now 9, because we've set it to be the 14's left. Once again, we ask ourselves, is the new node's value less than the current node's value? So new node is 5, current node is 9. So the answer to this is yes. Then we're going to ask ourselves, is there a left node on current node? The answer is no, so we need a little bit more code here. You can see that there is something not there. So we are going to add an else to our if. So if the current node's left exists, we move there. If it doesn't exist, we say that the current node's left is now the new node that we want to add. So we put the 5 there at the left of current node, and that's it. Now nothing's missing there, but we don't want to continue going through our loop because we've added our new node. That's it. We are done. So what we're going to do here is we're going to add a break. We looked at this early in the course. A break is used to exit a loop. So at this point, we set the left node of 9 to be the new node. That means we've added a node. We want to now stop going through our multiple nodes. All we want to do is now terminate. So we break. Also, something to take into consideration is what if the new node's value was not less than the current node's value? So this if statement here, we've got if new node value is less than current node value, we go left. But what if it's greater than the current node's value? We want to go right. So we are going to have an elif there to do just that. Notice how now all the lefts have been changed to rights. All that happens is if the new node is greater than the current node, for example, let's say we were trying to add 21, this would be true, so we would move right because it has a right node. Then we would be at 22. Once again, we would go through our loop, and now 21 would be less than 22, so we would go in here and set 21 down here. Hopefully, this makes some sense. We're going to look at some code, and hopefully that'll help as well, sort of cement this knowledge. And of course, something else that can happen is that we try to add a node that has a value that isn't less than or greater than a node. That may happen if we try to add a new node that has a value exactly equal to an existing node. So what we want to do in that case is, of course, to avoid duplicate elements. As soon as your tree starts having duplicate elements, you start running into some problems. Do you put the node left or right? So we don't want two of the same elements in a binary tree. All we have to do is add another if statement there at the top saying raise a value error if the new node's value is equal to the current node's value. So as you go through the tree, if you encounter a situation where the value you're trying to add is the same as an existing element, you can raise an error or, print something out. That's it for this video. I wanted to show you how to add new nodes to a tree. Now we're going to go into some code and work on creating our binary tree class where we can find elements, add elements, as well as print the tree out using our in-order traversal. I'll see you there.